Hi, welcome to my channel Industry 4.0. Today, in this video, you will understand the key steps of a data science project. This is Data Science Process Beginner's Guide in plain English. Please like and share the video and subscribe to my channel. So, let's start the video. Introduction. While data scientists often disagree about the implications of a given dataset, virtually all data science professionals agree on the need to follow the data science process, which is a structured framework used to complete a data science project. There are many different frameworks, and some are better for business use cases, while others work best for research use cases. In this video, we are going to explain the most popular data science process frameworks, which ones are the best for each use case, and the fundamental elements comprising each one. First of all, we will know what is the data science process. The data science process is a systematic approach to solving a data problem. It provides a structured framework for articulating our problem as a question, deciding how to solve it, and then presenting the solution to stakeholders. Data science life cycle. Another term for the data science process is the data science lifecycle. The terms can be used interchangeably, and both describe a workflow process that begins with collecting data and ends with deploying a model that will hopefully answer our questions. The steps include framing the problem. Understanding and framing the problem is the first step of the data science lifecycle. This framing will help you build an effective model that will have a positive impact on the organization. Collecting data. The next step is to collect the right set of data. High quality, targeted data and the mechanisms to collect them are crucial to obtaining meaningful results. Since much of the roughly 2.5 quintillion bytes of data created every day come in unstructured formats, you'll likely need to extract the data and export it into a usable format, such as a CSV or JSON file. Cleaning data. Most of the data we collect during the collection phase will be unstructured, irrelevant, and unfiltered. Bad data produces bad results, so the accuracy and efficacy of our analysis will depend heavily on the quality of our data. Cleaning data eliminates duplicate and null values, corrupt data, inconsistent data types, invalid entries, missing data, and improper formatting. This step is the most time-intensive process, but finding and resolving flaws in our data is essential to building effective models. Exploratory data analysis, EDA. Now that you have a large amount of organized, high-quality data, we can begin conducting an exploratory data analysis, EDA. Effective EDA lets us uncover valuable insights that will be useful in the next phase of the data science lifecycle. Model building and deployment. Next, we'll do the actual data modeling. This is where we'll use machine learning, statistical models, and algorithms to extract high-value insights and predictions. Communicating the results. Lastly, we'll communicate our findings to stakeholders. Every data scientist needs to build their repertoire of visualization skills to do this. Our stakeholders are mainly interested in what your results mean for their organization, and often won't care about the complex back-end work that was used to build the model. Communicate the findings in a clear, engaging way that highlights their value in strategic business planning and operation. Data science process steps and framework. There are several different data science process frameworks that we should know. While they all aim to guide us through an effective workflow, some methodologies are better for certain use cases. CRISP-DM. CRISP-DM stands for Cross-Industry Standard Process for Data Mining. It's an industry-standard methodology and process model that's popular because it's flexible and customizable. It's also a proven method to guide data mining projects. The CRISP-DM model includes 6 phases in the data process lifecycle. Those 6 phases are: 1. Business understanding. The first step in the CRISP-DM process is to clarify the business's goals and bring focus to the data science project. Clearly defining the goal should go beyond simply identifying the metric you want to change. Analysis, no matter how comprehensive, can't change metrics without action. To better understand the business, data scientists meet with stakeholders, subject matter experts, and others who can offer insights into the problem at hand. They may also do preliminary research to see how others have tried to solve similar problems. Ultimately, they'll have a clearly defined problem and a roadmap to solving it. 2. Data understanding. The next step in CRISP-DM understands the data. In this phase, we'll determine what data we have, where we can get more of it, what our data includes, and its quality. We'll also decide what data collection tools we'll use and how we'll collect our initial data. Then we'll describe the properties of our initial data, such as the format, the quantity, and the records or fields of our datasets. Collecting and describing the data will allow us to begin exploring it. We can then formulate our first hypothesis by asking data science questions that can be answered through queries, visualization, or reporting. Finally, we'll verify the quality of our data by determining if there are errors or missing values. 3. Data preparation. Data preparation is often the most time-consuming phase, and we may need to revisit this phase multiple times throughout our project. Data comes from various sources and is usually unusable in its raw state, as it often has corrupt and missing attributes, conflicting values, and outliers. Data preparation resolves these issues and improves the quality of your data, allowing it to be used effectively in the modeling stage. Data preparation involves many activities that can be performed in different ways. The main activities of data preparation are data cleaning, fixing incomplete or erroneous data. Data integration, unifying data from different sources. Data transformation, formatting the data. Data reduction, reducing data to its simplest form. Data discretization, reducing the number of values to make data management easier. Feature engineering, selecting and transforming variables to work better with machine learning. 4. Modeling. There are multiple options for data modeling. We'll choose which option is best based on the goals of the business, the variables involved, and the tools available. When selecting the modeling technique, we'll produce 2 reports. The first one will specify the modeling technique we're going to use. The second will document the assumptions our modeling report uses if our model requires a specific type of data distribution, for example. Once we've chosen our modeling technique, we'll design tests to determine how well our model works. For this step, our deliverable will be our test design. This may entail splitting our data into training data and testing data to avoid overfitting, which happens when we design a model that perfectly fits one set of data but doesn't work with others. It is essential to avoid introducing any bias into our data in this phase. Next, we'll build our model to address our specific business goals. When we do this, we'll deliver 3 items: a list of parameter settings, a description of the models, the models themselves. The final step in the modeling phase is to assess our models. We'll review them from both technical and business standpoints. Subject matter experts on your project team may also participate in reviewing our models. A model assessment will summarize the conclusions of our model review, including a ranking of models if we've developed more than one. At this time, we may revise our parameters and conduct another round of modeling. 5. Evaluation. In the evaluation phase, we'll evaluate the model based on the goals of our business. Then, we'll review our work process and explain how our model will help the business, summarize our findings, and make any corrections. Finally, we'll determine our next steps. Is our model ready for deployment? Does it need a new iteration or another dependency project? 6. Deployment. While deployment is the last phase in the CRISP-DM methodology, it's not necessarily the end of our project. During the deployment phase, we'll plan and document how we intend to deploy the model and how the results will be delivered and presented. We'll also need to monitor the results and maintain the model during the deployment phase. We'll conclude our project by creating a summary report and presentation. Afterward, plan to review the entire process to determine what worked and what needs improvement. OSM. Unlike CRISP-DM, OSM is not an iterative process. It's not as widely used as CRISP-DM, but it's more valuable for certain use cases. Because it omits business-oriented phases, it's ideal for projects focusing on exploratory research and is often used by research institutions and public health organizations. With OSMN, we're more interested in what the data have to say, as opposed to asking specific questions. Obtain data. Because OSM is not goal-driven, the first phase is to obtain data. As with other frameworks, we can use several tools, including web scraping, APIs, or SQL, to obtain our data. Scrub data. Regardless of what we plan to do with our data, it must be scrubbed before it has any value. Even clean data might need to be reformatted to make it usable. This is the most important step in any data project. Explore data. Exploring our data helps we develop a better understanding of any preliminary trends and correlations we see. We aren't testing any hypotheses or evaluating any predictions yet. Some methods we can use to explore our data in this phase include command line tools, histograms to summarize data attributes, pairwise histograms to discover relationships and highlight outliers, dimensionality reduction methods, clustering to uncover groupings, model data. The ultimate measure of a successful model is how accurate it is. Usually, the most predictive model is the best model. We can measure our model's predictive accuracy by how well it performs on novel data. Data modeling is accomplished with machine learning techniques using supervised or unsupervised algorithms. Supervised learning uses labeled datasets designed to train the model to make predictions or accurately classify data. Unsupervised learning uses algorithms to cluster and analyze unlabeled datasets. Unsupervised learning models are helpful for uncovering hidden patterns and correlations. Although both types of algorithms may be used, unsupervised models are particularly useful in the OSM process because they can help us find patterns we may not be aware of when we start our project. Interpret results. The final step in the OSM model is to interpret our results. At this point, it's important to note that a model's predictive and interpretive powers don't always coincide and may even conflict. A highly predictive model may make it harder to interpret the results, not easier. A model's ability to predict relies on its ability to generalize, while a model's interpretative power can provide insights into a problem or domain. We may want to find a model with a good balance of predictive and interpretive capabilities, or we may want to focus on one over the other. It all depends on our project goals. Importance of the data science process. Following the data science process gives our work structure and order. If we follow a proven formula, our workflow can proceed smoothly, and we can be sure that we aren't forgetting something. A good data science process gives us confidence in our results because it's proven to produce the most accurate results. The data science process we choose will guide us through the necessary steps for collecting data, transforming it into a high-quality input, building and evaluating models, and interpreting and sharing our results. If we're interviewing for a data science job, showcase projects that follow the data science process to demonstrate our knowledge.